Alright, in factoring trinomials, it's helpful to have a little bit of a roadmap to follow. So here's one that I refer to for the more basic trinomials or polynomials. Look for GCF. Are there two terms? Difference of squares. Three terms. Is there a leading coefficient? Do you have four terms? But this system of rules isn't actually complete for what we're trying to do here. You might want to amend these rules or just have this rule in mind, but I need the highest exponent first. Okay, that's the way when you factor, that's how we set it up, with the highest exponent first. So maybe even in front of GCF, I don't know where you want to put it, arrange polynomial in descending order. Okay, so that'll be our first step. X squared is the highest exponent. I got to get these out of the way. So you'll arrange this as x squared. That's a positive x squared. I don't have to put the positive sign. The next term would be a negative 20x. And the last term would be a positive 99. Okay, I'm going to slide this up now. Alright, if there's no leading coefficient, nothing in front of x squared, you simply take the last term and list all the factors. 1 and 99, 2 won't work, 3 and 33, 4 won't work, 5 won't work, 6 won't work, because if you double 3 you get 6. I can't cut that in half nice and neat. 7 won't work, 8 won't work, 9 goes in 11 times. We've listed all our factors. Okay, now paying attention to the sign a little bit here. If this is a positive 99, and this is the result of multiplication, the only way you can get there is positive times positive or negative times negative. If this middle term is negative, I couldn't have used two positive terms. It must be two negative terms. So I'm looking for a sum of negative 20. And again, these signs are the same. Will anything here give me a sum of negative 20? Those right there will. That won't, and that won't. Once you find this on a problem where there's leading coefficient of 1, or you can say nothing in front of x squared, you basically have your answer. To get an x squared, all you need is an x here and an x here. And then you simply plug in, well, make this a little more colorful, negative 9, negative 11. And if you multiply this binomial by that one, you will see that you get your original polynomial.